Okay guys, so this would be our last lecture for the midterms. This would cover chi-square until prediction. Okay, so let's start with chi-square. Now, chi-square is a non-parametric test, just like your Kruskal-Wallis. It's a non-parametric test. However, this time it deals with what we call frequencies. Now, when you say frequencies, it means our data is counted instead of measured. Now, kapag sinabi po nating nabibilang lang natin, then our data is measured on a scale, or rather on a level that we call at least ordinal. And then, it could also be classified as data that is discrete. Okay, so again, si chi-square was very effective when we have data that is measured in frequencies in the level of ordinal, not scale. So, ordinal lang po tayo. And then that the data is also discrete. Ibig sabihin, binibilang lang po natin at hindi natin sinusukat. Now, chi-square has three different functions. It has the function of goodness of fit, independence, and homogeneity. However, take note that these are chi-square functions as opposed to what some might think of chi-square variations. Okay, function lang po sila at hindi sila variation, and thus, even though iba-iba po yung gamit nila, they actually use the same formula, which is chi-square is equal to the summation of the quantity of O, which is for observed values, and then E for expected values, squared divided by E, again for expected values. Okay, so before we proceed with the computation, let's first discuss the concepts of our chi-square functions. So, starting with our chi-square test for goodness of fit. Now, the chi-square test for goodness of fit is particularly effective if you have data that is measured or that includes ratio. By the way, it's a test of significant difference between the observed and the expected values. Gusto daw niyang malaman kung may significant difference yung observed or yung nakita natin doon sa expected or doon sa ating ina-expect na values. Now, again, the goodness of fit, the chi-square test for goodness of fit is particularly effective if the data includes ratio. Kapag sinabi po nating ratio in data, that would be the expected part or the expected number of individuals, at least in part, na ina-expect po natin. Okay, so let's try and use our knowledge para ma-compute po natin yung expected values na nawawala dito. Okay, so simple lang naman po yung formula, just a bit of a disclaimer. The formula is very simple, and also the examples provided in this video is your activity. So we will not be, or I will not be computing for the chi-square in the two examples here, but rather I will just be guiding you on how to compute for the missing values so that you can use the formula on your own. Okay, now let's start with our chi-square test of goodness of fit example. Now, like I said, it's very effective if our data includes ratio. So, check na po siya dito kasi meron po siyang isang column dito. It's a separate column that includes the ratio. So, basically, binigyan po tayo ng year level 1, 2, 3, and 4. 1, 2, 3, and 4. And the respective ratio for each of those year levels. So, paano natin i-compute yung expected values? You simply take the total value divided by the total ratio and then multiplied by our ratio or individual ratio. Okay? So, subukan po natin. Total value is 1,000. We divide it by the total ratio, which is 20. And then for year level 1, we multiply the value with 10, in which case we get an expected value of 500. And then that's it. You get the expected values, you rinse and repeat, and then you have your table of expected values. Okay, so para po mas clear sa atin, subukan natin for another turn. So 7, subukan natin sa 7. Let's have our total value, which is 1,000, divided by the total ratio, which is 20. And then you multiply that quantity with whatever our observed, or rather whatever our ratio is. So in this case, 7. And then the answer would be 350. So lagay po natin sa expected value natin, 350. And it's as simple as that. Okay, so wala na po tayong problema. Alam na natin how to compute for the expected values. Alam na rin po natin how to compute for the formula. Since alam naman po natin, and wala naman pong mahirap dito sa formula natin. But just take note that if you have 4 individual observations, so in this case, meron tayong year level 1, year level 2, year level 3, year level 4, dapat 4 different different terms din po tayo when it comes to the chi-square formula. So, itsura niyan is O minus E squared divided by E plus O minus E squared divided by E plus O minus E squared divided by E. So, kung apat po yung terms natin, or rather, apat po yung ating values, apat din po yung terms na gagamitin natin. So, this is for year level 1, this is for year level 2, this is for year level 3, this is for year level 4. I-add po natin yan because again, huwag po natin kalimutan itong summation. Okay, so that about concludes it for the test of goodness of fit. Now, subukan naman po natin sa chi-square test of independence. Now, our chi-square test of independence is unlike what the name suggests, is actually a test of association. So it wants to see if there is a significant correlation between a certain event and a certain effect. Now, in this example, ang event po natin is smoking. And then, ang effect natin is cancer. So, gusto daw nating malaman if smoking causes cancer. Very simple. Very simple concept. Tinitignan natin if a certain, again, kung ang nangyari ba ay nakaproduce ng isang epekto. Okay? That would be the chi-square test of independence. Now, to compute for the expected values, in this case, same lang po yung formula sa taas, sa goodness of fit, same computation. But to compute for the expected values here, it's very simple. So that would be column total multiplied by the row total divided by overall total. Very simple. Yes. So, subukan natin. Let's try to compute for our number 14 dito sa non-smokers, sa 14. So, non-smokers with cancer. Let's try to compute for the 14. Now, again, kunin po natin yung column total. So, that would be 59 times our row total, which would be 85, divided by our overall total, which is 180. And then, kung ano man po yung sagot natin, that would be the expected value for 14. Okay? Sige, para sa mga hindi pa nakakasunod masyado, subukan natin ulit. Or let's try to make another formula for another value. Nasubukan po natin si, let's say, number 5. Very simple lang po siya because yung column total niya directly below. So, 39 multiplied by the row total, which is 65, divided by the overall total, which is 180. And then we have our expected value for 5, or for heavy smokers without cancer. Okay, and then once you fill the table, kapag meron ka ng 6 expected values dyan, using the same formula, rinse and repeat lang po tayo, pwede na tayo mag-proceed with our chi-square formula. Again, like I said, kung ilan po yung observed values natin, kung ilang beses po tayo naggamit ng computation for the expected values, in this case, 1, 2, 3, 4, 5, 6, 6 na pirasong chi-square formula din po yung gagamitin natin. So, O minus E squared over E hanggang makaabot tayo sa pang-anim na O minus E squared over E. Saan po natin kino-compare yung critical values or rather yung computed chi-square natin? Again, sa table of critical values of chi-square. Okay, very simple lang naman po yung concept ng chi-square. So, I guess you have all the tools. I have given you all the tools to compute for chi-square. At least all of the preparations needed to compute for chi-square. So, ang kulang na lang po is yung last concept natin, which is a chi-square test of homogeneity. Yung chi-square test of homogeneity natin is simply like your Kruskal-Wallis. It's a test of difference for multiple groups, non-parametric. Now, sir, ano po kayang pinagkaiba? What's the difference with our Kruskal-Wallis test? Very simple difference, the types of data that each of those tests deals with. Si Kruskal-Wallis po, it deals with data that is measured on a ratio level. Ibig sabihin, sinusukat na po siya. That data type is also continuous. So again, sinusukat. Kapag chi-square naman po, binibilang lang again yung data. So ito po yung kadalasang may encounter natin kapag nagsasurvey tayo and so on and so forth. Okay? Again, ang pinagkaiba lang po ni Kruskal-Wallis at ni chi-square test of homogeneity is that this chi-square or this test deals with data that is counted. Or simply put, frequency po. But again, same concept. It's a test of difference for multiple groups that is non-parametric in distribution. I guess that's all for chi-square. Susubukan po natin ang correlation naman. Now, correlation is relatively simple. So, wag na po nating i-discuss masyado yung ating parametric correlation. Again, by the way, sa correlation po, ang ginagawa lang po natin, like the chi-square test of independence, ay tinitignan natin if a certain event causes a certain effect. Nakakapag-produce ba daw ng effect ng isang event? Okay? So, meron po tayong dalawang test. Like almost always, meron naman po. You have your Spearman rank and the Pearson R. Pinagkaiba lang po nila yung data distribution. So, si Pearson R is parametric. And then, si Spearman rank naman po ay non-parametric. Like I mentioned before, and I have mentioned a few times before, kapag sinabi po nating rank, most likely, itong test na po ito ay non-parametric. Because again, our non-parametric test deal with rank instead of the actual means or the actual average of the dataset. Okay, now kung titignan po natin yung formula ng Pearson R dito sa correlation, very simple lang po siya. X and Z or X and Y lang po yan. X times Y, summation of X squared, summation of Y squared. So, very simple lang po natin gawin. So, kayo na po yung bahala doon. But then, meron po tayong discrepancy dito sa ating Spearman rank kasi meron po tayong isang value na ngayon lang natin na-encounter, which is d squared. So, yun lang po yung gagawin natin for today. Titignan natin kung paano po i-compute si d squared. Okay, so let's start with the computation of our d squared. Unang-unang gagawin natin is rank x and rank y. Tulad po ng Cruz-Galois ranking natin, or just like our Cruz-Galois ranking, we simply ranked from lowest to highest. So, subukan po natin. 5 is the lowest, 1. And then 6 is the second lowest, which would be assigned 2. Next is 8, given 3. And then 10, which is 4. 11, which is 5. 12 is 6. 15 is 7. 19 is 8. And the two 20s, again, we get the average of the rank. So, 9.5 and 9.5. Bakit? Kasi 10 plus 9 or 9 plus 10, which would be the respective ranks divided by 2, which is also 9.5. Okay, so subukan naman natin yung y rank. Again, we're simply ranking per column, just like how we rank our Cruz-Galois data. So 5, 50, and 60, that would be 1 and 2 respectively. And then ang kasunod na po niyan is 70. May 79. And then you have your 80. And then you have your 82. Have your 85. 88. 90. And then 107. After getting the ranks of our x and our y, we simply subtract the values. Madali lang po, D stands for difference in ranks. So 1 minus 1, 0, 2 minus 2, 0, 5 minus 5, 0, 0.5, we have 1, we have 0.5 again, negative 0.5, 1, 0, negative 1, and then you have another negative 1. Okay? And then d squared, as the symbol suggests, we simply have to square our d. So 0, 0, 0, 0.5 squared is 0.25, 1 squared is 1, 0.25 again, 1, 0, 1, 1. And then we simply summate, and then we get 4.5. Then pwede na po natin gamitin si formula. So r square or Spearman rank is equal to 1 minus 6 times the summation. Wala na po tayong summation kasi nasummate na po natin. So simply 6 times 4.5 divided by n. By the way, n po natin is just 10. Bakit po sir naging 10? Kasi look, if you can observe and probably deduce, x and y came from only one person. So, isang tao lang po yan. Okay, so therefore, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N would be 10. Minus, times n squared minus 1. Sir, bakit po nawawala yung squared nito or yung exponent niyan? Hindi na po siya squared kasi kung mapapansin po natin, d squared na po yung na-compute natin dito. And then we simply have to summate. And then yung sagot po doon ay yun na yung gagamitin natin sa formula. Okay, so since madali lang naman po yung formula natin, ano po kaya yung sagot? RS would be 0.97 with a qualitative relationship. Qualitative description of a very high relationship. Now, tignan po natin yung symbol. It's positive, or rather assumed to be positive. So, it is considered to be very high positive relationship. As simple as that. Sure, saan po natin nakuha itong very high positive relationship na yan? If you will check your handouts, you have a table of ranges. So, yung range po natin ay 0 point something to 0 to 1. Yun po, doon po natin makukuha yung description ng ating relationship. Okay? So, that would be it. Take note lang po when computing for the R-square or the correlation. Tandaan po natin, hindi po tayo pwedeng bumaba sa -1. Hindi rin po tayo pwedeng tumaas sa 1. Okay? So, bakit po? Because 1 would indicate a perfect relationship. -1 would indicate a perfect negative relationship. And more than that would no longer make sense. So -1 to 1 lang po tayo, yung range natin. Okay? Now, once we establish correlation, pwede po tayong gumawa ng prediction models. Now, prediction models is just like correlation. So, by the way, first step po ng prediction is correlation. But the thing is, bago po tayo makapag-predict, kailangan ma-establish muna yung significant correlation. Sir, ano po kaya yung prediction? So, si prediction po, very simple lang po. It establishes the gravity of the effect. So, simply put, sinasabi lang po siya sa atin kung anong mangyayari if these values increase or decrease or simply change. Anong mangyayari sa y natin? And that would give us a formula, itong prediction po natin, that would give us a formula that would allow us to compute for y given a change in x. Sulat natin para hindi malito. Compute for y given a change in x. So, ganun lang po yung concept niya. But, however, meron po tayong tinatawag na single and multiple. Single and multiple refers to, like your ANOVA, the variables that affect the change. For example, meron ka ditong variable b. And then you have your variable a, variable a1, and variable a2. And all of these would affect our variable b. However, kapag isa lang po yung pinag-uusapan nating variable, that would be single. Kapag marami na po tayong variables na nakaka-apekto kay variable b, then that would be considered to be multiple linear regression. Okay, by the way, our prediction models is otherwise known as the regression models. Okay? Now, question. Kapag si variable a, variable a1, variable a2 ba? For example, si variable a tumaas ng 1, and then 1 din kay variable a1, and then another 1 for variable a2, would our variable b increase by 1 3 times? Okay, answer, hindi po. Sometimes, our 3 variables vary in the effect kay variable b. Ibig sabihin, kapag tumaas ng 1 si variable a, definitely tataas ng 1 si b. Paano naman kapag tumaas ulit ng 1 si variable a1? So, depende po yan doon sa gravity ng effect niya sa variable b. It could increase by 0.5 or it could increase by 3. Depende po sa, again, epekto or sa lakas ng epekto ni variable a kay variable b. Baka mamaya yung effect niya is a bit large, so ganyan yung epekto niya, malaki, as compared to the other two variables. So, case in point, ibig sabihin, hindi po pare-pareho yung tinataas ni b, even though pare-pareho yung tinaas ng variable a, variable a1, and variable a2. So, as simple as that lang po yung correlation natin. Hindi na po natin itatackle or we're no longer going to tackle the manual computation for linear, multiple, and single regression because it's a bit complicated for our level. So I'm just going to teach you how to perform it in computer applications. Okay, that would be all. for our last topic for the midterms. I hope you learned something, or I hope that this lecture has helped you in computing for the chi-square and the correlation. Okay, thank you for listening. Bye bye.